Hello, this is an update on my panel. This is the panel that uses the Team Digital hardware. So I believe it's 29 switches and 64 outputs, which are for the LEDs. So what's happening here is half of the outputs are connected to the green LEDs. You can see a couple of them are turned down over here. So what happens is it's for routing. So when I press the appropriate switch for the right route, then the LEDs will turn on for the blocks that are have been selected. All this extra added wiring here. This is for the lights are bicolor LEDs, so they do red and green. So the way it is internally they're all wired up for green, but there's an extra pin on there that is accessible on the top because I didn't make it as part of the circuit board. It was too complicated. So what I've been doing is I've been wiring up all those extra pins to wires, and then they come out over here, and then what they're going to do is they're going to end up connecting to the balance of the, since I'm using like 30, let's say 32 of the green inputs on the Team Digital boards, and then I have the other 32 I'm going to use for the red. So what's going to happen is when there's going to be when the block will be occupied, then that LED will go either from off, which is the route not selected as you see now, or the route is selected, it goes to green, or it'll be overridden with red if the block is occupied. So even though the block might not be selected, if it's occupied it'll be red. If it's selected and unoccupied it'll be green, and if it's not selected and not occupied it'll be off. So that's how that board is, and like I said, the extra connectors. So I'm going to have to fish those wires back underneath into the box. You end up getting a little bit bigger box, so those cables are a little bit neater, and eventually this will have a cover over it, and just the little LEDs and the push buttons will popping through because those wires are actually below the surface of the LEDs. So I should be able to fit a cover over it, and then have a nicer design of the diagram of the layout. So that's that board. And then here is another updated version, or this is the first time I'm doing this. What I actually did here is I have the same board because you know, those printed circuit boards, I made was a minimum order of 10. So what I did here is I put just a single color LED green. And so you see, and these are all like flush with the board, and I got the low profile switches, so it's just like a testing board. So what I'm actually doing here is so these are just green, no bicolor, and I'm testing it with the MGP Panel Decoder boards from a company I found in Sweden, and this has two of those boards. Each board has 16 inputs for the turnouts selection, so you program which switch operates what turnout, and then it has a sort of a serial connection for the LEDs, and each board does, I believe it's 64 LEDs. So and that's like almost like Christmas lights, where it uses, I think it's called a WS2811 chipset, and they become like programmable. So what happens, like I said, it's on a Christmas light string type thing. So at one end you have 3 wires. It's a positive, ground, and a data, and then it just daisy chains to all the other lights. So each light actually has like a chip on the light. It's like those lights that they have LED lighting. And what happens is let's say you have 64 LEDs in a row, but at the end you only have 3 wires, the plus, the ground, and the data. So with this circuit you could say, okay, turn light 1 on or off, light 2 on or off, and so forth, and that's the way that operates. So if I wanted to have RGB lights, I could go in that direction too. So you know, each light could be any color or whatever, but for the purpose of the way this board was designed, they used that networking, LED networking, I'll call it. And so now you can pick any LED or any sequence of LED, but they're all in parallel instead of individually wired up, whereas these guys, each LED has its own input on the board. So in this case, like you see there, there's 64, let's see, 32 green LEDs and 32 red LEDs, so then you end up needing 64 physical wire connections. Whereas in this case here, you only need the 3-wire connections to do a whole 64. And since there's 2 boards, because each board does, I believe it's 16, yeah, 16 turnouts. So I need 29 or 30 turnouts. So I needed 2 boards. So technically, so now I have my my 32 switches, but then I can have one string of 64 lights on one of the boards and another string of 64 lights on the other board. So it's pretty neat how that adds up. So I'm just working on the functionality of how what's going to happen as I flip the turnouts, because in this version over here there's the smarts, whereas as I select the routes, I have the logic that is in that is part of the CSCE boards, which I tell it, okay, if I flip let's say for the route for the first track, flip all these turnouts, but then if I select for the second track, check that the first track, if any of those turnouts were deselected, well then they have to be turned off, and that cascades through the whole thing. So you only want to have, like in the case of the yard here, let's say there's 10 tracks, you only want one of the 10 tracks on at a time. Whereas if the turnouts were triggered, like if you had the push buttons, if you had one push button for each direction of each turnout, well then you would need a lot of push buttons and so forth. And but then this board, what happens is, the way this guy is the turnout is the switch is selected to the output of the LED, I should say, is set to a turnout. So what happens is you might end up when you press, let's say, the first route, the turnouts will flip, the lights will go green. When you select another route, a few turnouts will turn on, and then those lights will go green. And as you select the turnout, since you're selecting them, the lights are turning green, but there's no checking back like it is on the other board, where it says, okay, well then that turnout is selected, yes, but not for that route. It's actually selected for another route. So it ends up that all you end up seeing is that as you end up selecting routes here, all the LEDs are going to start turning on. So which is not what I want to do. I'll give you an example. Here, I'll press this button here. Let's see, and then there's a whole logic that's has to still be worked on. So in this case, I press the turnout, the LEDs turned on that route. Let me see if I select this route. See that LEDs turned on, but this guy also turned on, because one of these turnouts that selected this route, since you triggered the turnout, it said, oh, okay, that's that address for that turnout. Let's say number 1 was triggered, so I'll turn the light on green. But now it doesn't know to turn it off because the other one is selected. And as I cascade through, let's see. So you're going to see it's going up. And sometimes more routes will select, because the same turnout that the LED is triggering multiple routes. But if you look back at this board, you see as I went up, see each consecutive route goes off. See, I'll press this route, that guy will come on. Press this route, that guy comes on. See, so it turns this one off, whereas back here the lights are just starting to turn on and go all the way up. So it has the advantage, like I was saying, as that with the lights of the cascading using the 3-wire functionality, as opposed to that one which has the independent pins for each wire. But then the problem I have is when I select the routes, it's actually not selecting the route, it's actually selecting a turnout, and then you have this issue. So I have to try and figure out, they have a functionality with a route table. I'll have to see how that works. The other thing is that they can trigger the LEDs to turn on with, these are actually turned on with feedback information. It gets complicated, feedback information. So I have to see how that feedback information could be used to turn on some LEDs and not turn on the other LEDs. So that's the progress on that. So thanks for listening. Bye bye.